The question I wanted to answer for this assignment was, how do NOx emission trends influence depletion of ozone? NOx is the term that describes the nitrogen oxides NO and NO2. The majority of stratospheric NOx comes from natural sources, such as bacteria breaking down compounds in the soil and oceans. NOx is also emitted anthropogenically by things like burning fossil fuels, agricultural processes, and biomass consumption. NOx cycles in the stratosphere by several catalytic cycles. The two shown here are ozone-destroying cycles. In cycle 1, we lose two odd oxygen molecules, O3 and singlet O. We similarly lose two ozone molecules in cycle 2. Each of these cycles is favored in a different part of the stratosphere. The ratio of singlet oxygen to ozone increases with height, so at higher altitudes, cycle 1 dominates. In lower altitudes, there is more ozone than singlet oxygen, so cycle 2 is more favored. These data come from a paper published in Science magazine that examined NOx emission trends in the United States. NOx became the focus of ozone depletion once CFC levels began to fall after the Montreal Protocol of 1987, as shown in the graph. The authors state that nitrous oxide is the single greatest ozone depleting substance currently, and is expected to remain dominant through the 21st century if emissions are not controlled. This graph projects the ozone depletion potential of NOx over the next few decades. Ozone is a greenhouse gas, but it shields the Earth from the sun's UV rays. Less ozone means more direct sunlight can reach the Earth's surface, causing temperatures to rise. This graph shows the global warming potential based on the current emission trends of NOx. So how is NOx removed from the atmosphere? NOx catalytic cycles are terminated by these reactions. The species on the right are called reservoir species. They hold nitrogen in these forms, preventing it from continuing the catalytic cycles that destroy ozone. Some NOx can actually slow ozone depletion from other sources, such as halogen radicals from CFC emissions. In these reactions, the chlorine and bromine species are converted to reservoir forms by reacting with NO2. This means that there is a middle ground for atmospheric NOx concentration. Too much NOx depletes ozone, but too little NOx does not prevent ozone depletion from other sources. According to the EPA, NOx emissions in the United States have steadily decreased over the last few years. However, we must continue to monitor their levels closely to find the optimum balance to ensure sustainable ozone levels in the future.